Welcome back, explorers. Today, we dive into the fascinating world of engineering as we uncover the secrets behind the construction of underwater tunnels. Have you ever wondered how these incredible structures are built beneath the ocean waves? Get ready to be amazed as we take you on a journey below the surface and show you how underwater tunnels come to life. In today's video, underwater tunnels are constructed. There are currently three main methods used in tunnel construction: the blasting method, the immersed tube method, and the shield tunneling method. Previously, the blasting method was more commonly used. Before construction, engineers analyzed geological conditions and the size of the tunnel to determine the most efficient blasting plan. Multiple drill arm machines bored equally sized holes at predetermined explosion sites. Experts then calculate the right amount of explosives to avoid collapses and insert them into the drilled holes. Finally, the explosives are detonated in stages, with each explosion advancing the tunnel slightly. After each detonation, concrete is poured to reinforce the tunnel section and prevent collapses. While this method is relatively fast and low cost, it has a high risk of cracking and water leakage due to the vibrations caused by explosions. Therefore, it is rarely used in underwater tunnel construction today. Instead, the immersed tube and shield tunneling methods are preferred for their stability and precision. The immersed tube method is the most widely used and safest method for building underwater tunnels. First, large prefabricated concrete segments are built on land. These standard concrete sections are about 217 meters long and weigh over 73,000 tons. Each segment contains two large chambers for highways, one for railways, and another for maintenance and service access. Tugboats then tow each segment to the construction site, where they are carefully sunk into a pre-dredged trench and connected with millimeter-level precision. Once in place, the concrete segments are pulled tightly together and water is pumped out to prevent leaks. Rubber gaskets are placed between the joints, and a layer of sand and gravel is spread over the segments to keep them anchored. A famous example of this method is the Hong Kong-Zhuhai-Macau Bridge Tunnel, which was built using the immersed tube technique. The third and most advanced method is shield tunneling. This technique uses a giant tunnel boring machine, TBM, operated remotely by specialists. It automates much of the process and is ideal for dense urban areas or challenging terrain. At the front of the TBM is a massive rotating cutter head, sometimes several meters in diameter, which can slice through nearly anything. The arrangement of the cutting blades depends on the geology of the tunneling site. Right behind the cutter head is a hydraulic system that pushes the TBM forward. As the machine advances, gaps between the tunnel wall and surrounding rock are quickly filled with quick-setting concrete to prevent water from seeping in. Every 2 meters, the TBM pauses within its shield for safety, while a ring of 7 precast concrete segments is installed. Skilled workers can complete this ring in just 25 minutes. These segments are reinforced with high-strength steel fibers and coated to resist long-term corrosion. Constructing underwater tunnels is an expensive process, but it has major advantages over building sea-crossing bridges, especially in areas with high traffic density or difficult environmental conditions. Unlike bridges, tunnels offer protection from harsh weather, such as storms, high waves, and strong winds, making them essential for critical transportation routes. And that wraps up our deep dive